Now we're going to introduce a commonly used Python library that will be helpful as we build models for the rest of the semester. And today we're just going to do it in the context of how to build a simple linear regression model using this library. But then we'll build on this as we introduce more complicated models in future lessons. So far we've been really doing the heavy lifting of model creation ourselves. We've been finding our optimal parameters using calculus. But what's much more common is to rely on data science libraries for doing this. So we will be using sklearn. It's also commonly referred to as sklearn. And what's nice about this library is that it really has broken down the modeling process and streamlined it into code that can implement model creation in just a few lines. So the lines you see there are actually the only lines you need to create a model. It's using what's called an object-oriented paradigm, and so different types of models are going to be defined as their own classes. And it's not at all something to worry about if you're not familiar with objects in Python yet. The easiest way I think of this is you think of sklearn as allowing you to copy an existing template of a useful model. So the first step is to make that copy, which is another word for what's called initializing. And then you will fit the model to the training data, and then you can use the model to make predictions. So those three steps can be completed in these lines of code. You initialize, you fit, and then you predict. And it's pretty clean to also extract your actual fitted parameters. You just call these attributes, myModel.coefficient and myModel.intercept. So let's hop on over to the notebook to see this in action. So before we jump into the shortcuts and the built-in methods from sklearn, I'm actually going to have us hard code the answers ourselves, just so you can see what's happening underneath the hood. So here's our definition of the slope, and so we can code it right here. Here's our definition of the intercept, and then we can define a function that says, great, given x and y data, return our best fit slope and intercept. So let's run these three. And then our prediction function is going to say, I'm going to predict these values. So if you give me an x value and a y value to create the model, then here is the predicted y values that will come out of the model. And if you want it at a new point, not in the original model, you'll give the x and the y and then the new point, and that will return your predicted y value. So we can visualize this using just a scatter plot, and then I'm going to plot the regression line on top. Let's see, sometimes if this doesn't work, you just have to rerun this matplotlib inline. Oh, I see. I need to run this. Yeah, there you go. And so this is what we had in the notebook, right? This is what we already saw, or what we had in the slides. If I wanted to predict the heights of a child whose parents had an average height of 70.5, I can plug that in, and that's going to give me 69.3. That's the height that I would get here, the y value on this point on the red line. So that's what's going underneath the hood when we now do this in sklearn. So I just wanted you to see that because we have only a few lines of code that does all of that, which is pretty nice. Let me zoom in. Okay, so step one, initialize the model. You have to import this linear model. I'm just calling it LM, and then you can name the model whatever you want. And then you do need to fit the model. And the one criteria is that your X values need to be entered in as a data frame. So in our case, we only have one column of values, but I'm going to put it in double brackets so that it's entered in the right form. The y-axis can just be a series. Then we hit my model, we write my model.fit, and then my model now has stored all of the information that you might want. So if you would like to get a prediction out, you can say, oh, here's now what I would predict If you put in X, the Y hat's going to store the prediction values. I'll even print the top of that so you can see. And then you can get the mean squared error right there, right? By taking the mean, and then there's my predicted values, Y hat, minus the original, and squaring them. So if we do that here, it's saying there's the model intercept, there's the model slope. I just printed out the predictions just so you could see for our first few X values. And then it shows you that the mean squared error is 11.4. And so we can also plot the output by grabbing the slope and the intercept. And so again, up here, you can see that from the attribute. My model.intercept will give you that value, my model.coefficient. It's going to output an array because pretty soon we're going to add more than just a single predictor. So you'll see that your coefficient, you may have more than just one coefficient, but that's coming in a future video. So here, if I just want to plot this, it's the exact same information as above, but I'm just using the output from sklearn instead. And again, if you want to get a prediction out, you do the same process. However, you will need to put this in as a data frame. And this is just giving me a warning because I'm just giving it in without labeling, you know, that this would be the parent average height. I'm not labeling that this is my X, but it's still giving me the correct answer. So you can ignore that warning as long as you're sure that it knows exactly what input this refers to. And I only have one input in this case. So that was a quick overview of how we can do it manually, as well as then using built-in functions to create our least squares regression lines.